بسم الله الرحمن الرحيم. الحمد لله والصلاة والسلام على رسول الله. كيف الحال يا شباب؟
الحمد لله تمام.
طبعا أنا لسه ما أعلنت لكم. I just put in homework for chapter 9 وخليت الديو ديت حقه الجمعة الجاية، ف يعني chapter 9 homework is on now. اللي يبغى يبدأ فيه من الآن he can start. Of course we finished chapter 9 and I'm going to start chapter 11 today. And then on Wednesday, inshallah, I will make a revision class for the previous chapter for the exam. We're going to have the test, as you know, this coming Saturday, inshallah, at what time? 7 o'clock maybe? Or 7:30, I forgot.
I think 7:30.
نعم.
It's at 7 p.m.
Yeah. I think 7 والله ماني متأكد. طبعا you know that the test is coming. It's called the test, so
دكتور يعني يوم الأربعاء الجاي مراجعة للغرب.
الشباتر القديمة ما هو راضي يشتغل القلم عندي، ما ادري شو المشكلة. القلم اللي استخدمه ما هو راضي يشتغل، او البورد. نشوف شو المشكلة. لا شباب ما ادري شو المشكلة يعني. انا استخدم هذا عشان اكتب عليها. والله ما هي راشدة، ما ادري وش المشكلة. نرجع للماوس. الماوس صراحة صعب الكتاب فيه. Okay, بسم الله الرحمن الرحيم. Let's start. I will write with the mouse, and writing with the mouse is not easy job at all. All right, chapter 11. Of course, we finished chapter 9, and now we are in chapter 11. Why is that? Because we have finished chapter 10 before, right? All right, and What's the title of chapter 11?
Intermolecular forces.
Intermolecular forces. What do you mean by intermolecular forces?
The forces between the molecule.
The forces between the molecules. The forces between the molecules. All right? And we're going also to talk about the physical properties of liquids and solid. What did we discuss in chapter 10?
Gases.
Chapter 10, I cannot write now. I'm writing with the mouse. It's not easy at all compared to the pen. We talked about gases. Now we're going to talk about physical properties of liquids and solid. All right, good. Very first question. This is the gases, and this is the liquid, and this is the solid. Why the molecules in gases are far from each other? The molecules here are closer, and in the solid, they are very well arranged. Why is that?
Because of the state?
Yeah, but the most important thing is what? The intermolecular forces. Okay? Intermolecular forces, the forces between the molecules. Now, do you think the intermolecular forces in gas, is it strong or weak?
Weak.
Why?
Because they are far from each other.
They are weak. They are very weak. Why? Because they don't exist.
Kinetic energy is high.
No, but the most important thing that there is no forces to hold them to each other. No forces to hold these molecules together. All right? When you go to liquid, there is much stronger, much stronger. Much stronger forces between them, much stronger. When you go to solid, they are very strong. Very strong. The forces are very strong. That's why they are very well arranged and they are actually solid. All right. انتظروا دقيقة بقى بحاول الكتابة صار مرة صعبة. still ما فايدة ماني قادر أحاول أكتب بالقلم والقلم ما هو شغال. All right, let's go back. All right, Bismillah, again one more time. The forces between liquid gas is very weak. Forces between liquid is much stronger, and in solid they are very strong forces with each other. Okay. We call these forces intermolecular forces. We call them intermolecular forces. We have to know the name and understand what's the meaning of intermolecular forces. It's the forces between the molecules, between the molecules of the atom. It is the forces, attractive forces. What's the meaning of attractive? What's attractive?
جاذبة تجاذب.
جاذب.
Yes. The attractive force. The attractive forces between gases is strong or weak?
Weak.
Very weak. How about for liquids? Much stronger. And how about for solid?
Very strong.
Okay. Let me tell you this now. If we have NaCl, what's the charge on Na? And what's the charge on Cl? It is minus and plus. If there is another molecule, NaCl, then what will happen to the both molecules, this molecule and this molecule? What will happen to them? They will attract
each other.
They will attract each other. Is this attraction strong or weak?
Strong.
It's very strong, very strong. In ionic compounds, it is extremely strong. It's very strong. That's why you will see that all the ionic compounds are actually what?
Solids.
They are solid. They are solid. Example, salt. الملح الطعام. NaCl is the salt that we're using for food. All right. Is it solid or liquid or gas?
Solid.
It is definitely solid. So all ionic compounds are actually solid, and there are very strong forces between them, and that's why they are solid. Good. Now we're going to talk about molecular compounds. Molecular compounds. What do I mean by molecular compound?
Non-metal with non-metal.
Exactly. Molecular compound, they are non-metal with non-metal. Non-metal with non-metal. Example, if I have Cl atom with Cl atom, or molecule, Cl2 molecule, is there any attraction between them? There is no charges at all, and that's why there will be no attraction between them almost at all. Is this clear? No attraction between them, and that's why they are almost, there is no attraction, and they are definitely, Cl2 is what?
Gas.
It's gas. It's not liquid. It will be always gas. Good. Now, we have forces between these molecules. We will talk about them. They are generally called van der Waals forces, but there are more forces that we're going to talk about. Van der Waals forces. I will use this word one more time later, and I will ask you to memorize it. Let me ask you a question. If we have oxygen with oxygen, and if we have carbon with oxygen, which one will be, if oxygen with another oxygen with oxygen? You will find that there is no forces between them almost at all. In case one with oxygen and another oxygen with oxygen, there is no interaction between them at all. While for CO, we will find that there is slight attraction between them. Why is that?
Because COH is polar.
Because CO is polar. So there is slightly what? Positive in here and slightly negative in here. If there is slight negative in here and slight positive in here, what will happen between these two molecules?
They will attract each other.
Why? Because of the charges. This type of interaction is called dipole-dipole interaction. Dipole-dipole interaction. Do we see this interaction in HCl?
No.
HCl.
Yes. Yes.
Do we see it or not? We see it. What's the I want you to memorize what's the electronegativity of chlorine? 3.0. You must memorize this. And hydrogen?
1.2.
2.1.
2.1.
Okay, so there is a difference in polarity. If there is a difference in polarity, what will happen? This will be slightly what? Negative, and this will be slightly
Positive.
positive. All right, and they will attract each other, and that's how we see the HCl molecule. How does it interact with each other? And that's why if you have HCl and they want to compare it to, for example, H2 molecule, H, which one will have stronger forces between them?
HCl.
HCl. All right. Now HCl will have stronger forces between them. If the boiling point of hydrogen gas, H2 gas, is X, the boiling point, غليان, what will be the boiling point of HCl? Less than or greater than X?
Greater than X.
Greater than X.
No, less than X. Well, yeah, okay, sorry. Greater, more positive. Yes, you're absolutely right. Sorry, it should be greater than X, of course. Okay, so if HCl and HH, if the boiling point of H2 and the boiling point of HCl, then the boiling point of HCl is higher than the H2, but still it is gas. Good. Now, let's compare these molecules. All right. We have propane, CH3, CH2, CH3. Is there any dipole in this molecule?
No.
Why? Because I told you to memorize What's the dipole moment of carbon? Then the electronegativity of carbon.
0.5.
2.5, and hydrogen.
2.1.
And the difference is 0.4. What does that consider to be?
0.5. 4.
The 4, if it's 0.4, the difference, this means it is what? Covalent. It's considered to be covalent. Is this clear?
Yes.
Okay. So this is covalent compound. There is no polarity at all. Look at the other one, the diethyl ether. It's CH3. Now, is there a dipole in here, in this compound? Is there a dipole?
No.
It's like this and like this, but very weak. All right, because they almost cancel each other, but they are in the same, not in the same line, and that's why there is dipole. And look at the dipole moment is 1.3, and look at the boiling point. The propane minus 42. When we go to diethyl ether, it's minus 25. Okay, when you go to CH3Cl, CCl, and there is a dipole like this, all right, and it's not cancelled with each other, with anything else. So there is slightly more dipole, and that's why it is 1.9. What's the boiling point of CH3Cl? Minus 24. It's getting higher. Okay, when you go to CH3CHO, CCO, there's also dipole moment here, and the dipole moment is 2.7. Look at the temperature. What happened to the temperature? The boiling point. Increased to 21 because there is stronger dipole forces. Look at the last one, which is C, N, which is, and then H. There is a stronger dipole here. It's actually 2.9. So what happened to the boiling point?
Increased.
So generally, as the dipole moment increase, as the dipole moment, which we represented by U, if it increase, what will happen to the boiling point?
Increase too.
Also increase. Clear? This is clear. What type of forces we have here? It's called what?
Dipole interactions.
Dipole interaction. You must memorize the name. Dipole interaction. Now, let's talk about another force, which is known as hydrogen bonding. Hydrogen bonding. It's called H bonding. Very important. H bonding is a dipole force, but happen between hydrogen and one of the three elements only, which is nitrogen or oxygen and fluorine. Only three elements. And the hydrogen must be bonded to these atoms. So if we know in water, this is water. All right. Is there hydrogen bonding in water? Yes, there will be hydrogen bonding in water. Why? Because the hydrogen is bonded to which element?
Oxygen.
Oh,
Oxygen. Is it the three that the hydrogen must be bonded to in order to make hydrogen bond?
yes.
Yes. And what will happen if there is another water molecule in here? There will be attraction between the hydrogen and the oxygen. This bond is strong, a very strong bond. Very strong bond. It's called hydrogen bond, and that's why. What's the boiling of water?
100.
100, which is very high. Very high compared. You remember these molecules? Look at the boiling of these molecules. Only the last one was close to it, which is 82. But the rest, they're very minus 42, minus minus 25, minus 24, and so on and so forth. So this is the hydrogen is. Where are we going to see other example of hydrogen bond? Are we going to see hydrogen bond in NH3?
Yes.
Why?
Because N is high electronegativity atom.
No, it's one of the three that I told you. Very important. Only
Nitrogen.
oxygen, and fluorine in order to have hydrogen bond. All right. And what's the other condition?
With fluor.
The hydrogen must be bonded directly to this element. So nitrogen is bonded to hydrogen, and so there will be hydrogen bond. Give me another example. Are we going to see hydrogen molecule, HF? Yes or no?
Yes.
Yes, why?
Yes. Because hydrogen exists there and it attracts to
Fluorine is among the three: nitrogen, oxygen, and fluorine. And the hydrogen is what? Bonded directly to the fluorine. Clear? Next, let's say that we have what?
Doctor, about the H2O example.
Yeah.
الحين الهيدروجين بيساوي رابطة هيدروجينية مع الأوليوف المولكيول والأوليف مولكيول ثاني صحيح؟
عيد الكلام ما فهمت.
مثال H2O
Yes.
الهيدروجين بيساوي رابطة بيساوي هيدروجين بوندينج with O اللي molecule and O another molecule, right?
It will be done between, let me see, now, is there going to be hydrogen bond in these two molecules? Where is the hydrogen is going to take place in this water? This is the hydrogen bond. The dot is the hydrogen bond. It is between the hydrogen of one molecule with the oxygen of the other molecule. That's hydrogen bond.
طيب والهيدروجين مع الأكسجين اللي في نفس المولكيول ما بهيدروجين bonding؟
هذه covalent bond, very strong covalent bond. This is very strong, extremely strong bond. واضح؟
Yes.
The hydrogen bond is between molecule 1 with molecule 2, not with direct and this is the dot points here. It's also, this is the hydrogen bond, is these dot bonds. Can you see the dots? And this hydrogen bond, this bond in between the molecule, this is called covalent bond. It's very strong bond inside.
It's clear.
Clear. Very good. Now, let me ask you an example. Let's assume that we have this molecule, oxygen bonded to carbon and carbon, and there is hydrogen bonded to Cl, for example. Is there going to be a bond between this oxygen and this hydrogen?
Yes.
No. There will be no bond between this oxygen and oxygen, this oxygen and hydrogen. Why is that?
Because the hydrogen is not bound to oxygen.
Exactly. The hydrogen is not directly bonded with the one of these molecules. How about if we have water and HF? Like this example. Is there going to be hydrogen bonded here?
Yes,
Why?
because hydrogen is bound to F directly.
Because there is hydrogen and oxygen in one, and the hydrogen is bonded directly to what?
To floor.
To floor. To floor. And that's why there will be hydrogen bond, yes, in here, and no in here. Is this clear? All right, good. Because of that, we can see that, look at the molecule. Generally, I will discuss this in a while, but generally, as the molecule become bigger and bigger and bigger, then it become the boiling point increase. Boiling point That's why I do the mouse. Okay. Look at this example. Do you have your periodic table?
Yes.
Okay. Look at the elements oxygen. What's under oxygen? Sulfur.
S.
What's under sulfur?
Se.
Se. What's under Se?
Te.
Te. All right. Look at H2Te, and then you go from H2Te. What happened? This is the boiling point. In this side, the boiling point. Look at H2Te. As you go from H2Te to H2Se, what happened to the boiling point? Decrease, because it's bigger. Sorry, decrease because it's smaller. So the size is smaller, and so the boiling point decreased. And then we went from H2Se to H2S. What happened to the boiling point? Decreased. But when we went from H2S to H2O, the boiling point increased drastically. Why is that? Because H2O has what?
Bigger size.
No.
Hydrogen bound.
Exactly. Because H2O has a hydrogen bond. Hydrogen bond. Look at the group which is carbon. What's under carbon?
Si.
Silicon. And then?
Ge.
And then?
Sn.
Sn. Sn, if you go to Sn, the boiling point of Sn, H4, then you go to Ge, H4, it become lower, Si, H4 become lower, and CH4 is even lower. Why is that? Because as the size of the element or the compound becomes smaller, the boiling point decreases, and there is no hydrogen bond in CH4. Look at nitrogen group. What's under nitrogen? Phosphorus. What's under phosphorus?
As.
And what's under AS?
SB.
SB, exactly. Okay, let's look at SB, H3, and then we went to AS, H3. What happened to the boiling point?
Decrease.
And then from AS, H3 to pH3.
Decrease too.
But when we went from pH3 to NH3, what happened? Increase. Why is that?
The hydrogen bond.
H bond again. H bond again. And the same thing with fluorine. And under fluorine there is chlorine. And then under chlorine there is bromine. And then iodine. Look at the boiling point for iodine. And then bromine. And then HCl. And then from HCl to HF, the boiling increase. All right? The other third important force that we're going to talk, I want to say that hydrogen bond is much stronger, hydrogen bond, much stronger than dipole-dipole. Even though it's almost the same, except this is with hydrogen only. It is the same. The hydrogen bond is very similar to dipole-dipole, except it is special case of dipole-dipole, but much stronger than dipole-dipole. Good. The third force that we're going to talk about is called instantaneous dipole. Instantaneous dipole. Okay. And this happens when we have many electrons and there is no forces in it, but because the electrons are a lot, some electrons will come to this side and or to this side and become partial negative, positive here. Why? Because the electrons went to this side and make partial negative. And this is called instantaneous, لحظي, at a certain time. Instantaneous means what's the word? لحظي, at a certain time. And this happened in big molecule. The bigger molecule, the instantaneous dipole become more important. All right? Instantaneous dipole become more important, and that's why it's called لحظي. And that's why we come back to this force. What happened to the, let's talk about carbon group. Carbon group with hydrogen, they have no dipole at all. But what happened to the boiling point as you go from carbon to Si to Ge to Sn? What happened to the boiling point?
Increase.
Huh? Increase.
Increase.
Why? Because of instantaneous dipole. Instantaneous dipole take place in bigger, the bigger the molecule, increase boiling point, also increase. Is this clear? Boiling point. Boiling point increase. Boiling point increase the bigger the molecule. Now, instantaneous dipole take place in all molecules. And this force is known as dispersion forces. Dispersion forces. You must memorize this name, dispersion forces. So, and as I said, where is dispersion forces available? In which molecule?
In bigger molecule.
In all molecules. It increases with bigger molecule. I repeat my question. Where is dispersion forces is available?
In all molecules.
All molecules. But it become more important with
Bigger.
bigger molecule, it become more important. So we talked about 3 forces so far. Okay, this is known as dispersion forces. Some people also know it as London force. Dispersion is صفة يعني dispersion disperse. إيش معنى disperse؟ يتوزع. What's it dispersion in Arabic? Dispersion. I think توزع. think توزيع. I'm not sure. Okay, dispersion forces is also known as London forces. London forces, all right, which is this is the name of scientist, but more known as Van der Waals, also another scientist, forces, Van der Waals. I want you to memorize all the names. Dispersion forces, London forces, Van der Waals forces, Van der Waals forces. This is how to write Van der Waals forces. See, Van der Waals forces. I want you to memorize these 3 names. This is name number 1. What's the other name? London forces. The third name, dispersion forces. You must memorize these 3 names. Most of the time, we're going to use dispersion forces for them. All right? Now, we talked about 3 important forces. This is called hydrogen bond. What's the other one?
Dipole bond.
Dipole.
Attraction.
All right, and the third one? Third one.
Ionic.
No.
London force.
What?
Dispersion.
Yes.
London
Dispersion.
force.
What's the name again? Dispersion. Dispersion forces. All right, now. Dispersion forces. All right. Now the okay. Where is the hydrogen going to be available? Hydrogen bond. Where are we going to see hydrogen bond? And these are all, by the way, for covalent compounds, for molecular compounds, not for ionic. And that's why when you say ionic bond, I said, no, it's wrong, the word ionic bond, molecular compounds. Where are we going to see the hydrogen bond?
NB.
Whenever we see hydrogen bonded to directly to what?
N
O or N or F.
N or fluorine. All right? Good. Where are we going to see dispersion forces?
NB. Oh, no.
What? All molecules. Is this clear? All molecules, the dispersion forces will be available in all the molecules. But it is more important in what?
The bigger.
The bigger molecules.
Where are we going to see dipole?
In all hydrogen compounds except NOF.
Not hydrogen compound. Whenever we see dipole, when are we going to see dipole?
Whenever we have a molecular compound
Polar.
that have a
Polar.
There's no hydrogen here. Is this compound, are we going to see dipole force or not?
We'll see.
yes.
Yes, why? Because there is dipole moment. Whenever there is dipole moment and the difference in electronegativity here, what's the electronegativity of fluorine?
4.
4.
Yes, how about chlorine?
3.5.
3.0.
No, 3.0. 3.0. I want you to memorize these numbers from your periodic table. All right? Good. Now, let's look at CCl4. CCl4. Are we going to see any force in CCl4 or not? Which force we're going to see in CCl4? CCl4 is Cl, okay?
Dipole.
We will see dipole
Why?
attraction
Why?
because there's a dipole, polar.
Is this polar or non-polar?
Polar.
It is polar H bond, but the molecule is what?
This is non-polar
Why? You remember in chapter 9?
because
AB4E0 is non-polar if the terminal atoms must be what?
they're the same.
The same, and that's why this is non-polar. So what forces we're going to see for CCl4? What forces we're going to see? Are we going to see hydrogen bond?
No.
No. How about dipole?
No.
No.
No. How about dispersion?
Yes.
Without thinking, dispersion, US is available in everything. Okay, let's look at CH3, COOH. Last part is COOH. And then there is CH3. What forces we're going to see here? Are we going to see hydrogen bond?
No.
Hydrogen bond?
No.
Yes. Why yes? Is there hydrogen bond in this molecule?
Yes.
Yes, why? Because hydrogen is what?
Is bound to oxygen directly.
Exactly, and that's why there will be hydrogen bond. Is there dipole in this molecule?
Yes.
Why?
Because the hydrogen bond is actually a dipole attraction.
No, but there is also another dipole force
Yes.
between
C and O.
between carbon and oxygen. Is there dispersion forces?
Yes.
Yeah. Without thinking, whenever I say, is there dispersion? What's the answer?
Yes, also, always.
In all molecules, there will be dispersion. Is this clear? Good. Let's look at the third molecule quickly. The third molecule is actually CH3 C double bond O C H like this. Okay, CH3. Is there hydrogen bond in this molecule?
No.
Why not?
Yes, there are
Because
three.
No hydrogen bond. Why not?
because hydrogen
Because
is not bound to
Exactly. Hydrogen
to
bond that is
nitrogen or
exactly.
oxygen
Is there
or chlorine.
dipole?
Yes.
Yes, there is.
Yes.
Yes, this is the one, dipole. Okay, is there dispersion?
Yes.
yes.
Without-
Yes.
Yes, the last example, H2S. Of course, there is a difference in polarity like this and like this. Now, is there a hydrogen bond in H2S?
No.
Why? Because there is no oxygen, no fluorine. Good. Is there dipole?
Yes.
No.
Yes, because they don't cancel each other, the dipole. Clear? Is there dispersion?
Yes.
Yes, we don't have to think. All right? And so this is the answers. Good. What type of force do we have in here? We call this force, if there's water and Na plus, we call this force, we call this ion. And this molecule has dipole. Okay, there will be interaction between the ion and the dipole. Why is that? Because the ion has a plus charge. It will be attracted to which part of the dipole? This must be what? A partial what?
No.
Partial positive or negative?
Negative.
Partial negative. And this part is the partial positive and this other side. There will be, if this is a dipole, and there is partial negative and partial positive, there will be attraction between Na plus and partial negative here, all right? And that's why there will be attraction. Now, let me ask you another question. Why this one is stronger attraction than the first one? Yes?
Because we have full plus. Sorry. يعني كاملة.
What do you mean? What's the charge in here? Plus 2. What's the charge here? Plus 1. Which will be attracted to the other dipole? Yes?
MG.
Mg, because it has stronger force in a smaller area, and there will be a strong attraction. And we have the plus 2 over this small area compared to plus 1 over this bigger area. Which one has total charge bigger? Mg much bigger, and that's why this is stronger force than this force. Hey, all right. Now, let's talk about other subjects. We're going to talk about surface tension, viscosity, and vapor pressure. Surface tension. If you wake up in the morning and you look at your car, this is the top of your car, and it's very wet that day. رطوبة مرة. كيف شكل المية إذا كانت سيارتك very clean؟ هتشوف الماء صاير bubble like this, right؟ مرة لاحظتها؟ bubble like this. قولوا لي ليش؟ Why is that? I repeat one more time. أنت لما تصحى الصباح وتشوف سيارتك، خصوصا إذا كانت نظيفة، إذا كانت مش نظيفة مشكلة، بس إذا كانت very clean وكان اليوم مرة رطب، look at the water الرطوبة اللي صايرة على السيارة، تجد إنها bubbles like this. Bubbles.
Yes.
Why is that? Why it's bubbles? Why it's
It
not
condenses.
liquid?
of the high bonding.
لا الليكويد المفروض يمشي صح؟ بس هذا
Yes.
ما هو ماشي، مسوي بابل وجالس مكانه. ليش؟ Because of surface tension.
Because the attraction between water is greater than the attraction between water and the surface.
Exactly. This is called surface tension. Surface tension. There are forces between the water molecule and between the water molecule and the top of your car. This is called surface tension, and this is holding these molecules not to go. يعني water, when you put water in anything, if you put water in anything, the water should move like this. But because of the surface tension, especially if it's you're not forcing it to do anything, you will find that it will stay like this. Let me ask you another question. Viscosity. ايش هي الفيسكوسيتي؟ لزوجة. ايش معنى اللزوجة؟
The resistance of matter to flow.
Exactly. Resistant to flow. Why? Because it has become more closer to solid. Okay? أعطيكم مثال. If we have honey and water, which is more viscous?
Honey.
Honey is much more viscous than water. Okay, what's the reason? What's the reason? ليش honey is more viscous than water?
Maybe because of its density.
لا. Forces between the molecule in honey is weaker or stronger than water. What do you think?
Stronger.
Huh?
Stronger.
Much stronger. Forces in honey is stronger between the molecule, and that's why it become more viscous, because there are forces between the molecule. The molecule does not want to leave each other. They like each other. Okay. The last thing is called vapor pressure. What's vapor pressure? Vapor pressure, if you have liquid, any liquid, عطر، لما تحط عطر في الغرفة وتخلي الزجاجة مفتوحة، ايش تشم؟
Evaporate.
Right? You smell the perfume. Why is that? Because even though the perfume is here, why you smell it? Because there are molecules coming out of the perfume out, and you can smell them. العطر, you can smell it. Why? Because molecules are coming out, and this is making vapor. So the liquid is making vapor. Liquid is making vapor. All right, and this vapor is making pressure on the liquid. So there is vapor pressure. Because there are vapor here, we know الغاز دائما له pressure. فالvapor له pressure. Is this clear? Okay, so which one will have more vapor pressure? Water, all right, or let me give you example. الووتر is not a good example لأنه liquid، ولكن خلينا نقول تعرفون أسماء. Okay, let me give you example. For example, I mean, which one we're going to see more vapor pressure in it? Like CO. These are all liquid and can be gases, and they have smell. But let's compare this one to this one. Which one will have more vapor pressure, 1 or 2? One will have more vapor pressure. Tell me why.
Because it's smaller molecule.
Oh, because there is less forces. There is no hydrogen bond in here. In 1, there is no hydrogen bond. In 2, there is hydrogen bond, which makes it stronger. And that's why the vapor pressure of 1 is much higher, because the vapor come out of liquid because there is no force holding it together. Is this clear?
Yes.
We see surface tension like this. The molecules between each other, they attract each other like this. And that's why they attract each other like this. If they are in the middle, there is forces from all sides. So what's the net force for the one in the middle? What's the net force?
Zero.
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 The one at the top, what's the net force? What's the net force?
إلى الأسفل.
الأسفل. And that's why if you look at liquids in a small container like this, how do you see the liquids? Is this clear? Why is that? Because of surface tension. انتم ملاحظين اذا عندك تيوب زي كذا وحطيت فيها ليكويد وهي ضعيفه، يعني الليكويد تشوف ان سطح الليكويد like this. Why is it like this, مايل؟ Hello?
Because
Because of
the
the
forces
surface.
between the surface and molecules greater than
Because
forces between each molecule, each other.
at the surface there is a net force down. In the middle there is no net force, so there are no forces in the middle, but the top there is some forces. All right. طيب ليش مايل كذا؟ ليش ما يجي كله تحت؟ لأن في forces أيضا
في
بين
force.
liquid and
في force range.
the container. There is forces between the liquid and the container, and that's why it's folding like this. Is this clear? Okay. Liquid and the container. This is called capillary action. لما تروح للطبيب وتحط ويعمل لك العملية، يعني ياخذون دم من الأصبع، يحطوا تيوب وتشوف الدم يطلع لفوق. Why is that? Why the blood goes up?
اختلاف الضغط.
Because of attraction between the molecules and the container. The container, when the liquid comes there will be attraction between the liquid and the container, and this will start going up and up and up. This is called capillary action. Capillary action. The forces between the molecules inside the molecule with the molecule is called cohesion. So these forces, all these forces that you're looking at, all these forces are called cohesion. Cohesion between the molecules of the liquid water. But the forces between the molecule of the liquid and the container is called adhesion. So this force is called adhesion. And this force, the black force here, is called, what's the name? Cohesion. So what's the meaning of cohesion? Forces between what?
Forces between the same molecule.
Same molecules. And what's adhesion?
Between the container and
The
or
container
different one.
and the liquid molecule or whatever molecule. Okay, good. We discuss about viscosity and we measure it with this unit, not important. And let me ask you a simple question now before we go further. If we have this molecule, and water, which one you'll think it will be more viscous? The first one, the water, number 1 or 2? I will answer you, it's 2. Why is that?
Maybe because we have 3 hydrogen bonding.
Exactly, we have much more hydrogen bonding in this molecule than the water, and that's why it is more viscous. Okay, last thing, as I told you, whenever you put liquid in a container, what will happen to the liquid? All liquids will give you what? Vapor. Vapor. There will be vapor out of the liquid. All right. احنا نشوفها في المية لما يغلي، لما المية تغلي ايش يصير؟ لما المية تغلي
The liquid.
صح؟
The liquid change to vapor.
Vapor, but هو يصير حتى في lower temperature, but you don't see it because it is little, very little. But any liquid will always have vapor like this. And why? Because all liquids are volatile. Volatile means liquid goes to gas. That's the meaning of volatile. Volatile متطاير بالعربي. متطاير. ايش معنى متطاير؟ من ناحية علمية. Volatile. What's the meaning of volatile? Liquid will change to what?
To gas?
To gas. Liquid, volatile means liquid goes to gas. What's the reverse of volatility? العكس.
تكاثف.
Condensation. Condensation is the reverse of volatility. Volatile is the reverse of condensation. All right, this vapor, when it comes, it has pressure. And this pressure was calculated and found that there is a relation between the pressure of the gas and delta H of vaporization. What's delta H of vaporization? When liquid goes to gas, any liquid goes to gas, delta H for this reaction is called delta X vaporization. And it has a value, and we saw the rest. What is R?
Constant, maybe.
Gas
Yeah,
constant.
that's constant. You remember what's R?
Yeah, gas constant.
Yes.
0.0821.
Yes, but now here, no, it is 8.31
Okay.
joule. All right, and what's T?
Temperature.
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 In what?
In Kelvin.
In Kelvin.
Kelvin. Kelvin. Exactly. This is very important equation. It's called Clausius-Calibran equation. You must memorize even the name. Clausius-Calibran equation. That's important equation, but one more, much more important is this equation. You must memorize and memorize very well. It's called Clausius-Calibran equation. Okay, and it calculates the vapor pressure at two different temperatures, T1 and T2. You must memorize this equation very well, and I can assure you there will be one question in the final from this equation. You must memorize it and memorize it very well. Let's have everything. What's P1 and P2?
Pressure 1 and pressure 2.
Vapor pressure at what? At
T1.
T1 and T what? 2. Okay, what's delta H? Enthalpy. Enthalpy. Enthalpy of what? Which reaction?
Vaporization.
Which is what? Liquid goes to gas. And last thing, what is R?
Gas constant.
Gas constant. Gas constant. And what's
Doctor,
T1? What's T1 and T2?
gas temperature.
Temperature.
Sorry, liquid temperature.
Temperature and what?
Kelvin.
Kelvin.
Doctor, what is Ln?
What?
Ln.
Ln. Oh, what's Ln? Oh, very good. What's Ln? Math.
Logarithm.
Logarithm. It's available in your, look at your calculator. You will find what's Ln, which is natural logarithm. Is this clear? I hope this is clear. With this, I will stop here as usual, and then we'll go very quickly to these. All right, it's open now, and I just sent you the link. So go ahead and make attendance before you leave. And when you make attendance, you can leave right away.